Okay, welcome everyone. Let's start. Welcome at this fourth webinar already of part of the Occupational Exposome Week that we organized. Two projects that initiated, so the EXIMIUS project and the EPHOR project, both focus on the relation of different exposures on health outcomes. And both projects are part of a European network, the EHEN network, where 9 projects are coming together, focusing on exposome research. Today we have 2 presentations. They are linked to each other. So Miranda Lowe, who's working at IOM, will start with a presentation about different exposure measurements that were conducted in a case study. And Vivi Schlünssen, working at Aarhus University, will link that presentation to the outcomes and the results that come out of a case study in relation to health, respiratory health. So there are 2 presentations in this session. Miranda will start. If you have any questions, you can either put your question in the chat. We'll pick them up after a presentation or after both presentations. Or you can raise your hand if you have specific questions that you want to talk about. So Miranda, the floor is yours.
Right, thank you, Ilko. I'll share my screen, and if you can just let me know when I share it that you're seeing the presentation mode. Be great. Hang on a second. Okay, do you see the presentation mode now?
Yes.
Okay, thanks very much. Okay, so thanks very much. As Ilko said, we'll be talking about the exposure assessment part of the EPHOR study, and Vivi will talk a little bit more about how it has been implemented in her case study. Sorry. Okay. Slide changing? No.
No.
Okay. We'll just iron out the technical details in a moment. Let's see. Okay. Do you see the slide change now?
Yeah.
Okay.
It's okay.
So I'll be talking about this integrated approach for assessing the external exposome. And so again, we focus on the external exposome, which is in contrast to the internal exposome, which would be looking at biomarkers of exposure. So we're looking at capturing the environment through which a person moves. So today I'll explain a little bit more about the external exposome, what it encompasses. I will also talk a little bit more about then the methodology that we've developed in EPHOR to assess the external exposome. And this methodology is implemented in 2 case studies, one of which you will hear about later on from Vivi, and a brief section on discussion and conclusions. This is still a work in progress, so we are still processing the data, and I am showing you primarily preliminary results at this stage, and there will be more analysis to come. So if you haven't already heard about the exposome, it encompasses all environmental exposures, including workplace exposures that could affect health over the lifetime. So in EPHOR, we're focusing on the working life exposome. So we're looking at people who are working and trying to assess what their exposures or their exposome profiles would be over their working life and how it would affect their health. So this will include not just pollution or occupational exposures to things like dust or stress even, but also things like diet and lifestyle or non-occupational exposures. What we want to do is, because the exposome is both, it encompasses all exposures and a lifetime of exposure, we are looking at cumulative and synergistic effects, which you might consider also as a kind of complex mixture, but much more broadly than just chemical exposures. So why is an exposome approach beneficial when we're looking at the environmental impact on health? So we're exposed to many things every day, and therefore it gives us an ability to improve our ability to capture exposures and do better exposure assessment. And this can then help provide more informed public health strategies and targeted interventions to reduce exposures and therefore health risk. The other aspect of the exposome methodology is because of the technologies used, there is much more focus on personalized risk profiling or looking at individual exposures rather than using group level measurements such as, say, air pollution exposures based on an ambient air monitoring station. We're really looking then at personal exposure from that standpoint. And of course, as I mentioned before, because we're exposed to multiple exposures, this approach can help us understand the impact of a combination of exposures, particularly those at low levels, and how they would influence disease. So in EPHOR, we are using different methodologies, as you can imagine, because the external exposome is very broad. We are not necessarily capturing everything there, but we are capturing quite a wide range of different exposures. We are using wearable sensors to do real-time exposure monitoring for a set of different exposures. We are also using passive monitoring methods, as well as novel laboratory methods to screen for a wide suite of chemical exposures. So rather than focusing on one or just a few, where we're looking at on the level of tens or hundreds of different chemical exposures. We're also doing monitoring for allergens in the home using a passive monitoring method. And we complement this with daily questionnaires to gather information, contextual information about a person's daily activities. These, as I mentioned before, are implemented in 2 case studies, one on shift work and one on respiratory health. And this is implemented across a 5-day working week. So a little bit more about our methodology. So I mentioned before, it's very much focused on the person. And as such, you will see here in this figure, the different types of monitors that we're asking people to carry around with them for a week. So we have a passive sampling badge, which is very small. It's kind of the size of a pen that can be worn by a participant, and it captures both volatile organic compounds as well as semi-volatile organic compounds. For the analytical methods, we do the widescreen primarily on the volatile organic compounds. We also have the real-time sensor, which a person wears, and that will measure particulate matter, noise, UV, light intensity, and temperature and humidity. And we also have a physical activity monitor for a subset. One of the case studies, the respiratory case study, will be wearing, the participants wore a wristband which measured physical activity. And for the shift work case study, they used a heart rate monitor. You can see there that in the home, we laid out essentially an electrostatic dust sheet, which is then passively collecting dust and will be analyzed for endotoxin. And complementary to this, we are looking at health measurements, which you'll hear more about in the next presentation, such as lung function, biomarkers from blood and urine, as well as exhaled breath. So all of this information we hope to be able to combine to demonstrate the use of this kind of protocol in a short-term health and exposure study. So what do we plan on doing with the data? So as you can imagine, there's quite a lot, and these new technologies can provide new information that wasn't necessarily available for environmental health studies in the past. So as I mentioned before, we can do more individualized assessment of exposures and health outcomes. We will have a set of high resolution data, temporal data from the sensor, which you can see here on the right. It's relatively small. And in the picture, one of our staff is wearing it around his waist, and it measures. So we have real-time minute by minute data for particulate matter, noise, light, UV, temperature, and humidity. And this can then be linked to variation in short-term health effects, such as the lung function measurements, which I mentioned earlier. And it allows us to investigate exposure sources and determinants based on the time series. We also have multiple exposures with the chemicals as well as the sensor data, and this allows us to then look for correlation patterns between the exposures and potentially to see if there are any patterns between these correlations. Of course, there are challenges. There are challenges in this type of data collection. We will need more elaborate data processing because there's a lot more data that needs to be considered. And again, they are collected on different time resolutions. So the passive, the chemical and biological data is an integrated method or an average over the monitoring period, while the sensor data is real time. Additionally, there are relatively limited data analysis methods for exposome type of data, but this is changing as more exposome studies are being funded. And in this case, because we're collecting data on so many different types of exposures, not every exposure will be relevant for each individual. So we need to think about how to prioritize these. So I'll now go over some information about our study centers. So you'll see here in this table the different types of measurement measurement methods that we use. So there's a sensor box, which I mentioned earlier. There's an activity, which is the activity monitor. The How Am I is the app that the daily questionnaires are generated under, although for some participants, they chose rather to use a paper diary rather than the mobile phone app. The passive sampler, as I mentioned before, and for our shift work case study, which was 4 different centers, they were especially interested in more resolved information on light exposure, and therefore they have 2 different types of sensors for light, a HOBO and a ChronoWise, which also gave some information on light from a wavelength standpoint. And we also have the polar for heart rate. The respiratory case study consisted of 8 study centers, while the shift work consisted of 4 study centers. So you can see the total number of participants we have across both case studies is just over 1,000. The study centers, again, they were somewhat different in terms of their split between male and female. The shift work case study had primarily healthcare workers. So there were a couple nurses cohorts that were included, which would explain the bias towards the healthcare type of worker. And you can see in general, we had more non-manual workers than manual labor types of jobs. And again, more non-smokers than smokers. Most of the participants were of a middle-aged, either in their 40s or their 50s. So these are some preliminary results to illustrate the types of data that we have gathered, and they're descriptive results. So you can see here in the table the types of workers that we have and how many we have of those types, as well as by group. The percentage of time in this particular graph, the distribution of time spent at work involving light or moderate activity by the different groups. So you can see there's considerable variation in the percentage of time in light or moderate activity. And of course, some groups have more participants than others, and therefore the distributions will be a bit different between these. And this is also just for the respiratory case study, not the shift work case study. You'll also see here are the particulate matter concentrations, PM2.5 concentrations by different jobs. And surprisingly, they're relatively on average similar in exposure. Some of them we would expect to have perhaps higher exposures because, for example, drivers or builders, and we see some variation there where builders have higher exposures overall. Childcare workers and care workers do also appear to have higher exposures. And so we will explore this a little bit further in the analyses. Here you see again, noise, there's relatively less variation between groups, but within groups, there's quite a wide variation of noise exposure. So for the chemical exposures, this is quite interesting. So we used a screening methodology. So that means it's a bit of more qualitative methodology for looking at a wide suite of chemicals exposures. I don't expect you to be able to read the compound on the bottom, but this is to illustrate that we as I mentioned earlier, we were looking at hundreds of chemicals. So we've now isolated the top 50 highest concentration chemicals in each different country that was in the study. And you can see the darker red boxes indicate chemicals where there are higher concentrations were found. And then the lighter colored yellowish boxes are lower concentrations. So you can see there's quite a lot of variation between the countries in terms of the groups of chemicals that were found at higher concentration levels. To break that down and give examples of the types of compounds that we were finding, these are the top 10 compounds that were detected in the study centers. And you can see also the main applications in which these chemicals would be found. So these include things like limonene, some alcohols, and some of the siloxanes, which is quite interesting. Most of them appear to come from cosmetics or personal use products rather than, some of them may come from also occupational exposures such as disinfectants, etc. But quite a lot of them do seem to come from what people are using on their own. So this will be very interesting to explore further as we delve into the data more. Also, a little bit more breaking down of the passive sampler data. We looked, as you imagine, there are so many compounds. How do we make sense of it? We also then use a CLP labeling classification of the health hazard statements as an example. So you can see the most common chemicals with a health hazard classification are listed on the top table. And on the bottom table, you see the chemicals that were found at the highest concentrations. And we have a mean concentration. Now, these concentrations are somewhat uncertain numbers because these are analyzed not without standards for specific compounds, but it gives an indication of the levels that we are finding in our passive sampler data. And remember, these are things that people are wearing on their person. So they reflect their personal exposure. So what we plan to do is to, of course, delve into the data and query it and understand a bit better the patterns that we're seeing. But what we have found is that certainly these technologies such as sensors and the new analytical techniques that I mentioned for chemicals can really expand our capacity to characterize a very wide range of exposures compared to studies previously where we were looking primarily at one or a very specific class of exposures. So this is, of course, still a proof of concept. So as I mentioned, we are trying to understand what we can do with the data and what kind of conclusions we will be able to draw. We did find that it was quite challenging to implement such a comprehensive protocol. So if you recall, there's quite a lot of different samplers that a person would have to wear, and there is a requirement for some interaction with them. So that can be a bit of, it can be a challenge for both the participants and the field workers in order to make sure that everything works well. But certainly we have shown that it is possible to implement a comprehensive protocol in a research study. And certainly in the future, we hope we can refine this type of protocol to make it a bit more user-friendly for participants and still enable us to get the information that we would like to have on the external exposome. So the next steps is to use the data to build up our understanding of their external exposome profiles, and also to see if we can link that to short-term health effects in the case studies that I mentioned earlier on shift work and respiratory health. I do also want to say that this isn't just for research. We are very keen to be able to translate the research tools into practice. So we have put on the EPHOR toolbox, which you can see the link for there, our protocols and a little bit more information on what the sensors, passive samplers, and the mobile phone daily questionnaires can provide. And so there are guides there, there are videos there for scientists to look at our protocols, but also for practitioners to be able to see what these tools are. And certainly we would be happy to answer any questions about those in the future. We are also particularly interested in bringing the sensors to occupational health and safety practice, as we see this as a tool that can really help them monitor and manage their risks in a more effective manner. So we've done some stakeholder engagement in the form of a couple of surveys, but also focus groups to look at what people might be interested in learning about and what they may need to be able to translate the use of these types of sensors into occupational health and safety practice. And so we have developed an online guidance, which we will roll out soon based on this consultation with occupational hygiene practitioners. So as an example, you can see one of our focus groups in the pictures there, but also at the British Occupational Hygiene Society annual meeting, we had an artist kind of engage with people at the IOM stand, and we've illustrated some of the issues that hygienists have brought up in terms of barriers and facilitators to using sensors in their work. So that's all I have. And thank you very much to all the project teams which have participated in helping us develop the protocol, and certainly to the case studies for implementing them in their work. So I'd like to thank you very much for your attention, and can move on.
Thank you, Miranda. Applause in the teams, and also a question, or actually two questions in the chat. So the first one is
sharing. Sorry, should I stop sharing or leave it up?
You can leave it up, or okay. Maybe share the presentation. Vivi can share that presentation already, but okay. It's fine for me. And the first question is about passive sampling. Why did you use passive sampling instead of not choosing for active sampling?
For the chemicals and the biologicals? Yeah. Well, because we wanted people to carry this around with them for a week. It's more practical to have a passive sampling method because you don't need a pump, and it's relatively small and unobtrusive, so it's easier for a person to wear and use. Same for the biologicals. That wasn't a personal monitor, but it's just much easier to use passive methods if it's possible for doing monitoring over a long period of time. It's less intrusive for the participant as well.
Yeah, so it's a very comprehensive and all included protocol that you're trying to apply, but try to keep it as easy as possible for the study participants. Okay. And the second question is about physical activity. So could you describe the parameters that you measure that are linked to physical activity?
So basically, the method is based on accelerometry, and therefore the data is processed into different parameters, and we can essentially choose what would be of interest. But the ones that I showed there was classifications into light, moderate, vigorous activity. I don't know offhand exactly how data is processed, but that is pre-processed by the software that is available with the monitor. I know that sometimes it is possible to get, for example, METs, the metabolic equivalents, but you would then need to have some physiological measurements from the person, such as their weight and height and gender, I believe. So that what we will end up using in the analyses will be decided upon consultation with the case studies.
Okay. John raised his hand. John, please unmute yourself. Or is it applauding? John was trying to. John, do you have a question? Don't think so. And Miranda, maybe one question.
Was I muted?
Ah, yes, you were unmuted.
Sorry, I didn't mean to. I was raising my hand just to congratulate Miranda on the presentation, not to, I meant to be sort of doing a clap or something like that. So apologies, but it was very good. No questions there.
Thanks. Maybe one question from my side, Miranda, because there are also quite a lot of voice professionals present here, and you already shared something about what we're doing for sensors. In this study, of course, we applied different types of methodologies, and often as a voice professional, people are interested in one or a few chemicals. How would you apply these different methods, and would you suggest to apply basically these different methods also in their context?
Yeah, so actually the methods we chose because it's an exposome study to, for example, for the passive monitoring, to analyze a very wide range of compounds using what I would call not standard methods, and obviously the same for the sensors. In the work for sensors that we've been doing, this is something that, as we explained, they're not standard compliance methods, but what they add is the ability to relatively unobtrusively, and you can see how small the sensor is, measure in real time on the person, or you can even put it in as area samplers around your workplace. And they are less expensive than a lot of the equipment, the direct reading equipments that are available. In terms of the chemical analyses, I think many hygienists will also be familiar with the passive sampling methods, such as the organic vapor badges. One thing that is quite advantageous about this one is that is different from traditional methods is that you can measure both semi-volatile and volatile organic compounds. And that is something that I think isn't really common. So it is still a methodology in development, but I think there is certainly lots of room for working with professionals if people are interested to develop this technology more. And we don't have to analyze, so that these are screening methodologies, but we can then target the analyses more if there are specific compound groups or specific compounds that people are interested in. So I think that is something that is really advantageous, because often before you could only either measure volatile organic compounds or semi-volatiles. And often I think, especially for semi-volatiles, we're using active methods, but this is a passive method. Now, the issue, of course, is its long-term measurement, and passive methods, as those who are familiar with this methodology, you need a certain sampling time. So that would need to be worked out. But I certainly see this as a real advance for capturing a wider range of exposures for occupational hygienists. So I would really encourage the practitioners to get in touch with us if you are interested in exploring and helping us develop this methodology more in the future. The mobile phone app is also another one that's quite useful, because you can gather contextual information there, and it pings the user to answer certain questions at certain times. So that's another methodology which could be used by practitioners.
Okay, thanks. Two more questions in the chat. One is about other studies comparing the passive versus the active sampling. That you're aware of?
For this sample, I don't know if Ilko, you can answer that. I am not aware that we have an active sampler comparison, but I don't know if you.
I'm also not aware of really a comparison study. There must be really comparison studies for the methodologies, but
yeah, that's a good point, and I think that's certainly worth us having a look for. I'm not aware of any. I've only seen kind of the laboratory-based studies for this method. And
the other question is about occupational external exposome would more focus on compared to environmental external exposome for public. So how would that work?
What's the question again?
So this study is focused really on the occupational setting, but would it also be possible to focus more on the environmental part? I think that's the question.
Oh, the environmental part, meaning just the chemical measurements, because essentially, I think this can be applied for any study. It's just that we are choosing to focus on an occupational population. But the methods, so I don't know if it was clear earlier, they're not only doing the monitoring while they're at work, they're also bringing these measurement devices home with them. So essentially we're monitoring across their entire day's exposure for a whole week. So we are capturing also the environmental side of things. And there are other studies, of course, that also look at primarily more the environmental side, but we are doing both. It's just that we are highlighting a bit more the occupational side of things. So certainly, I think there is application to populations who are not necessarily occupational populations if people are interested in doing that.
Okay, thanks. I think it's time to move to the presentation of Vivi. Thank you, Miranda. And at the end we do some questions. So if there's still questions for Miranda, we also can do that at the end. Thanks. Vivi, the floor is yours. You're still on mute.
So, yes.
Yes.
Then I'll try again to share. So, can you see me?
Yes, perfect.
Yes.
Good.
Okay. Yes, so I will continue. So there will be a bit of overlap from Miranda's presentation, but I think this will function pretty well. So I just have to be so. I will provide you with a presentation of a short-term study on the working life exposome in the respiratory study, and really a real-world example. And many persons has been involved, both from Aarhus University, IOM, TNO, and KU Leuven. And now I also have an issue with changing. So here's the agenda. So first, I will elaborate a bit on why we are choosing to use an exposome approach, and also that there might be some cons also to this approach. And then dig a bit into the objective of the EPHOR short-term respiratory study, show you how we choose the population, and then try to summarize the different ways of assessing occupational exposures or working life exposures in reality. And then show some very preliminary results, and also what we are working on right now. And then highlight why this EPHOR short-term respiratory study, in fact, is quite unique. And then also some reflections about way forward. So until now, we have mainly in respiratory research used what we normally call one exposure, one outcome approach. And you can say it's pretty easy to interpret, and the relevant exposure metrics can be very comprehensively analyzed. And you can also say that the prevention measures can be straightforward because you know precisely what to target. But the problem is that you're only putting light on a really tiny bit of the problem. So as an example here, a study from California, from Eastman's group, among dairy farmers. So they were able to show that the lung function declines significantly more about dairy farmers compared to controls, and this was mainly seen among persons with asthma-like symptoms. And then you have the middle group, so to speak, studies where you investigate more studies at the same time. it can be a bit more difficult to interpret. But on the other hand, you're able to solve a bit more of the problem. And then we have the occupational, the exposome approach, where we in theory try to capture all exposures from birth and onwards. And what you see here on the right hand side is the surrounding environment involved in asthma and allergy. So it's both the working exposures, but also the environmental exposures and lifestyle, like Miranda already touched upon. And the issue is that it can be difficult to interpret. We are still working on that, and we need new and emerging analytical strategies in order to move forward with that. And you can also state that it might be a bit more complex to make targeted interventions, because you have to take a lot of exposures into account at the same time. But the benefit is that you really have the potential to solve a substantial part of the problem. And you are able to make much more elaborate analysis on vulnerable subgroups, important time windows, and also have the possibility to identify important mechanisms and pathways. So in this short-term study, we wanted to evaluate the impact of the short-term occupational exposome, or in fact the working life exposome, both on biomarkers, on respiratory symptoms, and also on lung function. And more specifically, we wanted to investigate how cross-week and daily changes in lung function and respiratory symptoms was related to the working life exposome among persons with mild asthma, and also how effect biomarkers was related to these occupational exposures. And furthermore, we wanted to shed light on how age, sex, and specific biological markers might modify these associations. So here you see the study population. That was the original plan. So our point of departure was two existing large cohorts. So one cohort was the European Community Respiratory Health Survey. It's a large respiratory survey going on since the 19th among more than 40 centers across Europe. And the other cohort was Constance's. That's a French cohort, again a population-based cohort comprising of more than 200,000 persons, where data are collected in multiple centers all around France. And in EPHOR, we were able to make a follow-up of parts of these cohorts, and that is what we call the long-term EPHOR respiratory study. And then from this subgroup, we wanted to invite 400 participants with mild asthma exposed to occupational asthmagens. So we really picked our participants to the short-term study among persons we have been knowing for decades. So a very detailed information about the selected participants. So as I stated, we want to include 400 participants with a job and mild asthma. But in the end of the day, we had to loosen the inclusion criteria a bit and focusing on persons with any respiratory symptom. And we also wanted to include persons that for sure were exposed to airborne asthmagens, but also again ended up loosening the criteria. So we focused on anyone holding a job where some of them was exposed to asthmagens at work. And still in the respiratory study, we were only able to include 146 participants, and I will come back to reasons for that later. But as Miranda also touched upon, we were able to include 146 participants from 8 study centers, most participants from Bergen and least from Spain, and then with a pretty similar distribution in the other centers. They had a quite elaborate clinical investigation both Monday and Friday morning. So initially they responded to a short questionnaire about, for instance, airway infections, use of medications, and other relevant information. And then we collected air in two different ways, namely as exhaled breath and as exhaled breath condensate. And both of these methods are able to measure hundreds of small molecules of relevance for the respiratory systems, but also for the body as such, and especially the exhaled breath is also called a breath biopsy. And then we measured the lung function, took a blood sample and a urine collection. And then during the work week, as Miranda also touched upon, they answered questionnaires in an app. So twice a day, they answered questionnaires primarily about symptoms, but also working hours and other relevant issues. They wore the sensor box in a belt, and then the passive sampler, the activity meter, and then they measured their own lung function 3 times a day using a more simple device than we use in the clinic. And finally, they placed this passive dust collector in their rooms for 3 weeks. And I will provide a few more details. So for the passive sampler, we collected both versatile and semi-versatile compounds. The activity sensor was able to measure physical activity, but also sleep patterns. And then the EPHOR sensor box measured light, UVB, sound, fine dust particle count, and temperature. And as Miranda stated, it was not only at work, so it was from Monday morning to Friday morning, and they also put the equipment close to themselves during sleep. So in principle, we have information 24/7. And the passive sampler, so it was developed within EPHOR, and very intriguing because it uses these two different ways of sampling. But I will not go more into details with that for now. The passive sampler, also called an electrostatic dust belt collector, was used to collect dust in the participants' bedrooms. And in this study here, we primarily used it for analysis of endotoxin. And endotoxin is a very commonly used marker for microbial exposure. It's a large part of the outer membrane of gram-negative bacteria. And we have also now piloted to measure allergens, but it seems like the levels are pretty low, so probably we will not do that. And then we collect material for the future, so we are able to also to assess the external microbiome in more details. So to sum up what we are doing with regards to the external occupational exposome. So we are collecting self-reported info. We are collecting this range of high resolution data where we really are able to assess exposures at work, but also outside work. And we are able to make a discrimination between these two because we know individuals' working time. And then we have the versatile and semi-versatile organic compounds and endotoxin, where we will have an average from Monday morning to Friday morning. But we are also looking at the internal exposome, meaning what we can measure in biological samples. So for blood, we are measuring metals and focusing on cadmium and lead. In urine, we measure quite a few PAHs, polyaromatic hydrocarbons of relevance primarily for combustion processes, and then also quite some metals in the urine. And as you can see here, we have made the analysis both Monday and Friday, so we are in fact able to assess changes in exposure, and also to use this data to look at variability within the measurements. But we also consider other exposures. So we consider smoking partly as self-reported data, but also measured in cotinine. We assess ambient air pollution because we have information about home and work addresses. So we use a tool developed in another exposome project, namely EXPANSE, where we will have access to different measures of air pollution, for instance, PM2.5, ozone, and nitrogen dioxide. And then finally, we also analyze different kinds of omics in the blood. Most importantly, we analyze DNA and RNA, and also we can also perform epigenetic analysis. The epigenetic analyses are important because by doing that, we gain knowledge about what genes are expressed and not expressed. And finally, we also measure proteomics. With regards to the outcome, just to sum up, we measure lung function and respiratory symptoms, but also a whole range of biological markers of susceptibility. For instance, quite a few immune factors, and also the proteins IKL40 and CC16, who have earlier been shown to be quite strongly correlated with lung function decline and also COPD. We measure acute phase responses, CRP and SAA, and we also have a measure for antioxidative capacity. And then we are able really to explore biological pathways in details, using, among others, the versatile organic compounds, the epigenetic analysis, and also the proteomics analysis. Yes, so here you see the characteristics of the study participants. On average, 58 years old, equal distribution of males and females, and in fact, very few smokers, mostly administrative and office workers, but also some skilled and unskilled manual workers. And you can imagine that having such a bunch of different and comprehensive data, it can be an issue with complete data. But in fact, it seems like for most of the participants, we will have quite complete data, which is in a way a surprise that we have managed that. But so that is really great. And with regards to the passive sampler, as Miranda also touched upon, you see here a list of the 6 most prevalent chemicals, and it's mostly from cleaning agents, personal care products, cosmetics. So this is maybe more reflecting the more primate domain of having a working life, and not so much at work. But we will dig more into that. So at least for me, it was a surprise, but that we were able to detect on average 112 chemicals per participant, and also to detect close to 800 unique chemicals. And looking at the distribution in the different sensors, we see some differences in the distribution of chemicals, with less in Iceland and most chemicals in Tartu. And now I will show you some very preliminary data. So here you see the results for cotinin. It's also clear from the cotinin that we do not see a lot of smokers. But for some of the sensors, we are indeed identify some increased cotinin plasma levels. And here is some preliminary data for interleukin 8. And interleukin 8 is important in the immune reaction against, for instance, bacteria. So it's a chemokine. So it attracts cells to be included in the immune response. And we in fact see some differences across sensors, and also, at least for some sensors, some differences between males and females. So what is going on right now? We are finalizing quite some analysis for the next few months. So an important paper is an descriptive exposure paper, including exposome profile analysis. And this exposome profile analysis will be very important in the studies where we're going to assess the association between exposures and health, in order to be able to deal with all this kind of different exposures. And also, given that our study population is relatively limited. We are now look at how different asthma phenotypes can be assessed from identification of different DNA, RNA expression, and epigenetic patterns, where we are focusing on DNA methylation. And then now working on the two, I would say, main studies, namely the association between cross-week and daily changes in occupational exposome and change in lung function and in respiratory symptoms, respectively. And then a descriptive paper on the exhaled breath condensate is also on its way. So the next step will to dig even more into the working life exposome and effect biomarkers, and focusing on biological pathway analysis, and also focusing on this different susceptibility factors we have, like sex and TC16 and IKL40. And then we will build a valuable data resource for the future. So it's already something are in place within the EPHOR project, but in the future and after the project ends, we will have a resource at Aarhus University with an remote access to data. So given the proper collaboration agreements and data processor agreement in place, the data will be accessible for others. Okay, so why is the EPHOR respiratory short term so unique? So first of all, we have an extremely well characterized study population. We have been knowing the participants for decades. And we have this very detailed information about daily and weekly changes in multiple exposures and outcomes with a very high resolution. And we can look at, for instance, peak exposures and time-dependent exposures associations in the way very few data sets are able to do. And then we have a unique possibility to identify pathways between the different occupational exposures and respiratory health, taking markers of inflammation into account. But we have also had some experiences with inclusion, especially. So we had challenges in recruiting enough participants. So we had to broaden the criteria. And the reasons for non-participation was that the study center was too far away. It took too much time, simply, and then the workload was too heavy. So with regard to recommendations for future studies, so it's really important to find the proper balance between being very ambitious on one hand, but also to have a realistic study protocol. And then some of the sensors, both the sensor box and also the passive sampler, was developed within the framework of EPHOR, and it's a long process and it's still ongoing. So maybe also a recommendation for the future is that, if possible, use existing and validated tools in a project like this. But of course, it's also very exciting to be a part of developing this type of tools. And then it's really key to have a precise and friendly user standard operating procedure in such a multi-center study. But in the end of the day, it's really worth it, because the data set now created, we believe, will be extremely useful for future analysis. So again, thanks to EPHOR and all the partners who have been taking part in this, and not at least a huge thanks to all the study participants who in fact did an immense work to help us. So thank you.
Thank you, Vivi. Nice presentation. Also for you people clapping in the chat.
Yeah, great.
There's a question in the chat. So quaternary ammonium compounds are very prevalent in cleaning products with suspected asthmatic activities. Did you, in the analysis for the semi-volatile organic compound, screen for these chemicals?
I think we did, and maybe Elke, maybe you can help me. At least it was on our wishing list, because in the beginning of the project we made a use wishing list for what to be able to capture both volatile and semi-volatile compounds. So I believe we analyzed for this, but obviously it hasn't been very prevalent in this study. At least it's not on the top lists from the passive sampler.
Yeah, no, I think you're right. So it's we have included some cleaning or chemicals that are part of cleaning products.
Yeah.
So in this one that was definitely on our list to
Yeah, because as I totally agree, it's a very important component in cleaning. But we will dig more into that. But for sure, it's not common among our 147 participants.
Oh, okay. More questions in the chat. One regarding urine sampling. So you mentioned that you measured that on Monday and Friday. Were these morning voids? And why did you select fixed dates for this, and not randomly during the different days?
Yeah, so we choose fixed dates in order to have as uniform protocol as possible. But in the end of the day, we can also see that we have some variations. So some of the study centers have in fact invited people on different days, and we had to take this into account in the analysis. So it was not morning void, because we couldn't ask people, because they had the urine sample taken by us. So it was in the morning, but it was not morning void, unfortunately. It was logistically too difficult to do that. Yeah.
Another question is about the breath samples. What was specifically measured in these breath samples?
So in breath biopsy, it was mostly focusing on versatile organic compound, but also in principle all small molecules who can be captured in the breast. But with a lot of focus on the versatile organic compounds. So that it's still work in progress, I would say, both for exhaled breath and exhaled breath condensate, for how many different molecules you can capture. But it's believed to be a pretty representative for what is going on in the respiratory airways, and even also a picture for what is going on in the organism as such. But it's a very long list, hundreds of different molecules.
I think Manash's also answered or added something to your answer in the chat.
And maybe Manoshi, if you can, because you know both methods better than me, so maybe you can also add something.
Yeah,
Well,
Manoshi said in the chat.
Yeah, I put it in the chat, but it's for the exhale breath VOCs, as you mentioned, it's untargeted analysis, but we have identification of at least 40 or 50 compounds right now, but some of them still have to be identified. So that's work in progress. And for exhale breath condensate, it's also untargeted proteomics, and we have quite a lot of peptides which we are working on, as Vivi mentioned. Yeah.
One question from my side, Vivi, because we seems years ago already COVID, but well, we had a period of COVID in the beginning of this project. Do you still expect to see some impact, or not necessarily about the recruitment, but maybe more in results in terms of people still having effects of long COVID, these type of results? Do you?
Yeah, so you know, it's a small, it's 146. We have information about it, so we know we have been asking about COVID, so we know their COVID history, whether they were vaccinated or had the disease, or so we are able to take it into account in our analysis. But I do not expect that we will be able really to come up with something solid with regards to consequences of COVID in this relatively small cohort.
Okay, you might get some hints of
maybe
directions.
at least we have the information, but yeah.
Okay. I don't see any more questions in the chat, both not for Miranda and also not for Vivi. So I think we can close, but not before I thank both Miranda and Vivi for your excellent presentations today. As I mentioned, this was the 4th webinar of this Occupational Exposome week. Tomorrow we have the final one. Ayuka and someone from the EXIMIUS project will present there something about the health effects, but also what we see in clinics, and so the results of really the exposures and people ending up in clinics and really getting the disease. So if you're interested in that topic, then please join us tomorrow. It's around noon for European time. Thank you very much again, and have a good day, evening for the people in the different countries. Thank you.